Alright, we got a big delivery in today. It's the VECYS water dispenser with ice maker. The model number is BYCZ581. And so this is just a water dispenser, like you'd see in an office maybe, that you put a 3 or 5 gallon jug of water in the top. And this one has a compressor, so it does refrigerated water, cold water, room temperature water, and it also has a heater so it can give you hot water. In addition, in the bottom down here, there's an integrated ice maker. Now, I'd love to play with this today, but it has a compressor that's an oil-filled compressor inside. And so when it was delivered, you know, the delivery guy is carrying it sideways and so forth, and there's a big warning on top that says, hey, make sure you leave this upright for 24 hours so that the oil in the compressor, you know, goes down to the bottom. So tomorrow, we're going to open it up and play with it. Now, the entire shipping weight of this package is 44 pounds, so it's big, it's bulky, it's relatively heavy, but it's certainly possible for one person to carry this around and put it somewhere. Alright, to use this water dispenser ice maker, you're going to need a thing of water, a jug of water. This is a 5 gallon one. It weighs about 41 pounds when it's full, so it's almost, not quite, but almost as heavy as that unit itself. And so if you're a little slight, older, you may have difficulty lifting this up and putting it in. Now, it is possible to get a 3 gallon jug, which only weighs 25 pounds when it's full. It's very light when it's empty. So if, you know, lifting 5 gallons of water isn't your thing, you can do maybe a 3 gallon jug. And it's, you know, not quite half the weight, but 25 pounds is a lot more manageable than 42 pounds. Now, this guy cost me about $30. This one was $15 delivered. It's specifically the Premo water thing at Walmart where you can take an old used one in and get a new one out. So it's kind of a water bottle exchange program. But if you're looking for 5 gallon ones, this was the cheapest source I found for one of these. Now, I made a tactical blunder in that I should have unboxed this guy and then let it sit for 24 hours upright, because I'm going to have to try to unbox this guy without turning it on its side, and we'll see how successful I am with that. Alright, so this guy has styrofoam around all of the corners and top and bottom, so it's pretty well insulated from bounces and shakes inside of that box. There's a warning sticker on the side. It says, hey, don't plug it in until water can run out from the hot water tap. So I think they're basically saying make sure there's water inside the hot water heating element before you plug it in. Keep distance from the wall when you install the machine for airflow. Turn the power switch off and unplug the machine when not in use for a long time or no water in the tank. And keep the machine away from flammable and explosive materials. So I believe the compressor might be a sealed compressor, but there's several fans I saw that might cause you know, sparking inside the fans perhaps. So they're basically saying it sounds like, maybe it's just the heat it generates, but for whatever reason, don't keep it near flammable or explosive materials. Now, the back of the unit has a sticker here with lots of specifications, and it has what looks like 2 drain ports. So this one says guard against scald. On here says it's the ice maker drain. Now, there's a fan and what looks like a radiator unit in that one there. This guy here has an opening for air to move out, but there's not an actual fan behind it. And it looks like there's some wiring and tubing and stuff back there. So this back panel is some type of plastic. The black material is a metal. So it's shipped with this protective plastic in addition to the bag that was around the whole thing. This is the water inlet. There's the post in the center there. There's a thing that says open and close, so apparently you can take this bit off to, I don't know, clean perhaps. Or maybe if there's an adapter for a different style of water bottle. But this looks like the very standard kind of, you know, 5 gallon jug water bottles. We have the front panel. There's a fault light. There's a power light. And then there's some settings. It looks like hot water cold water ice making. It says, hey, here's the hot dispenser, and it says guard against scalding. And there's a lock button here. There's fresh water, which I'm assuming is room temperature water, and then there's cold water there. And then we have here the power cord kind of wrapped around from the back and kind of stuck in place with this little piece of tape. So that comes out there. Kindly note, please make sure the water level in the ice storage tank always do not exceed the baffle or need to release from back sewage outlet. Also some blue plastic on the side, and we need to pull that tape off for this door to open. And then inside the door we have here some trays, it looks like some more trays, and an ice scoop plus the manual. So this is the little ice scoop that they include with the unit. And it has what's obviously a clip meant to clip into something somewhere. I looked around inside the ice compartment and I could not find a place to clip that into. The manual doesn't say anything about it, so I don't know if this is an ice scoop that came with a different unit or if I'm just missing the obvious clip point and I just didn't find it. You know, it's a little bit flexible. You can kind of bend it with your fingers, but it feels like it's super smooth, you know, so the idea I think is that nothing can grow on it or stick to it. So it's perfectly serviceable as an ice scoop. If you don't like it, you can always buy an aftermarket, you know, metal stainless steel ice scoop or whatever and use that instead. So this is the ice storage area, and up here you can see those are the things that drip down into the water, then they freeze and make ice cubes, and then they pop back up and heat up and the ice cubes drop off. And there is some type of, I believe, a sensor switch here. I believe that's probably detecting water in the bottom, and if it gets up too high, it will turn off the ice maker. Alright, the manual is short, sweet, and pretty much to the point. They have some warnings about not burning yourself, not electrocuting yourself, that type of stuff. Little schematic, basically what I've already shown you. There's nothing surprising in the picture here, or picture of the control panel. So they basically say when you first plug it in, it's not going to do anything, it's just in standby mode. If you want hot water, you push the hot water button. The buzzer will beep, it's going to start flashing. When it's hot, then it will turn on. Cold water, you push the button, it buzzes, it will start to flash. When the water temperature reaches the set point, it'll be turned on. Ice maker, push the button, it'll beep, and then it'll start making ice. It'll take about 10 minutes to make each cycle of ice. They have some specifications here. They basically say it's a 500 watt heater. The ice making or cooling water is 2 amps. De-icing is 2.3 amps. So basically it freezes ice cubes on those little metal things and then it heats them up, and so the ice cubes drop off. It uses R134A coolant, 72 grams, which is nice thing just in case, you know, somebody wants to refill this with coolant. It says it can store 13 kilograms of ice, or maybe it can make 13 kilograms of ice in 24 hours. So I think reading between the lines, it's about a half a kilogram or 1 pound of ice every hour. Net weight 18 kilograms or about 44 pounds. So they include a circuit diagram which basically says there's a main circuit board, there's a remote power, you know, control panel circuit board. Kind of nice having this schematic. If one thing goes wrong, you can kind of debug it and know where to plug in a new one. And down here they say, hey, if the fault light is on, check these other lights and here's what's gone wrong, you know, so which sensor didn't work, you know, how to fix whatever problem it is. So it's not very extensive, but I think it has kind of the key, most important points about the machine. Now, they didn't mention anything about the operation of the hot water lock, so I'm going to have to investigate that. The manual, most notably, didn't tell me anything about what to do with these little trays, and I suspect this is an ice tray, probably to go between the top and bottom of this little ice compartment, and so I think it goes down there in the back, and I'm not 100% certain which way it goes forward, but we're going to try it with the 3 tabs to the back. Right, 3 tabs to the back looks to be appropriate. It fit in there pretty well. You lift it up, you might notice there's this little notch that fits into that thing there. So that guy separates the ice from any water that drips down below the ice. Just by looking at the shape here, I can tell it's probably supposed to plug into the top of that door. So that thing goes in there. It has this little plastic thing that pops out, and there's just a reservoir there. So if you spill water in there, you're going to have to pull it up and carry it to a sink and dump it out. So try not to spill water. I'm not sure how I feel about the drip tray opening with the ice compartment. I guess it's fine, really, because it's not like you're going to be getting water and ice at the same time, but it feels a little weird. On the other hand, if that tray was fixed, it would make getting things out of the ice compartment harder because there'd be a lip on the top. The fact that there's not a drain from here to the back makes me wonder, hey, why do we have two rear drains on the back? There's one up high that says, you know, watch out for scalding, and there's one down low that says it's from the ice container. So these guys have little turning knobs on them. I am going to leave and they look like they have a seal, like a plug in there. So yeah, that's a plug to seal them. So I am going to leave the plugs installed and these guys screwed on. But theoretically, with the right pipe and adapter, you could put drain lines from this guy and, you know, kind of wire a permanent drain line to some type of drain if this was somewhere that had access to a drain. Alright, this is a 5-gallon purified water container, and it has a little sticker that says lift here, and it's stuck on there quite well, so I'm get some fingernails in the game there. I'm actually ripping the sticker a little more than lifting, but here we go. Alright, so we lift that guy up, and there is a piece of kind of a, I would say, kind of styrofoamy looking bottle top seal in here. And I think, I'm not 100% certain, but I think this thing will just go in there, you drop it down and something pierces this and then the water starts flowing. So we're going to try that. Now it has this thing here, you can rip that off and pull the thing off. But my suspicion is you're supposed to use this just as it is through that hole. Alright, so putting a 5-gallon water bottle into this sucker. Alright, it looks like it's supposed to look, I think. We have air bubbling up. I'm assuming at some point this guy is going to fill with water and the air will hopefully stop going up. Either that or water's going to start coming out somewhere. Okay, I believe this guy is done filling up this little bottom part. So it should be safe to turn on now, but before I turn it on, let me just try dispensing water with no power. So it looks like this switch here is just a mechanical switch. Same thing for the cold. I figured out how the hot water lock works. It's nothing complicated or tricky. It just means you have to push the hot water button before you dispense water out of the hot water area. So it's not exactly super child safe, but it prevents accidentally bumping against this thing and just having hot water come out automatically. Alright, let's plug this guy in. Alright, we have a single beep and the light above the power icon is turned on. Supposedly it's in standby mode. I am going to turn on the hot water heater. It is 5:29 and it starts well, it's supposed to be flash. Oh, there's flashing, yeah. So the red light is very slowly flashing. And I'm going to wait until it's done flashing. So while the hot water is heating up, I am also going to push the button for the cold water. And I hear the compressor turn on down at the bottom. And I believe it is now going to be making cold water. The cold water light is also flashing on and off slowly. It's in sync with the hot water light. So basically when it says, hey, I'm working on stuff, both of those lights turn on for a couple of seconds and they turn off for several seconds. I'm going to leave the ice maker off for now. And I turned on the cold water thing here about 5:31 p.m. and we'll see when it finishes its cycle, or it gets the water as cold as it thinks it needs to be. Alright, sometime between 5:40 p.m. and 5:41 p.m. this red light turns solid. So it's indicating that the hot water is at temperature, and any water I get out of there will be max hot temperature. And now the cooler is still working to bring the little bit of water down to a cool temperature for the chilled water out. Alright, I'm going to withdraw kind of a standard 8-ounce coffee cup full of hot water. Alright, so I'm getting 181, 180, 179. I think, the coffee mug is starting to absorb some of the heat from the water, but it was at least 180 degrees coming out, maybe 185 coming out. So it's definitely hot enough to qualify as scalding or hot water. Now we're down to, 175, 176. So the mug is definitely very hot to the touch now. So the heat from the water has heated up the mug, and that water is still 175 here. So decent amount of hot water. Now the red light here is still solid lit. So I don't know how much hot water I need to draw before the internal reservoir gets cooled off enough it has to turn this thing back on and start flashing. I don't know if it starts flashing again or not, but it looks like the first cup is definitely plenty hot. Okay, it is 5:51 p.m. and the cold water is ready, so it's turned solid. The compressor for the refrigeration unit has turned off, and so when that happens, you know that it's down to temperature, and this is a solid blue light. So if you hear the refrigerator turn on and then turn off again, you know it's back down to temperature as soon as it turns off. Now the hot water I depleted by using 3 cups, and it's still flashing. At some point that's going to turn back to solid red. So the fresh room temperature water here has an ambient temperature of about 79 degrees Fahrenheit. Now I believe the ambient temperature in the house is closer to 75, so it's possible that the fresh water goes sort of near the hot water reservoir, and it picks up, a degree there. It's certainly not warm, but it's ambient temperatures. Now, what I consider the main feature of the water dispenser is the cold water chilling feature. So we are going to test the cold water that comes out of this guy. This light is solid blue, so it's it's down to temperature, and that water comes out at 47 degrees Fahrenheit. So that is definitely cool. Not so cold my teeth immediately hurt when I drink it, but it's definitely chilled water. Now I don't know how big the reservoir is, but my second cup also came out, at 44 point some degrees Fahrenheit. All right, the compressor is turned on, and so I'm going to wait until the water is chilled down to its chill point, and once it turns off, then I'm going to see the temperature of each cup I pull out and see how many cups before it starts getting warm. Okay, the compressor for cooling the water has turned off. It took about 8 minutes for the length of that cycle. And we're going to start seeing the temperature of the water coming out here. So it's basically about 44, 45 degrees Fahrenheit, and that is an 8-ounce cup. So that was the first cup, was about 45 degrees Fahrenheit, maybe 44. All right, the water in the second cup is actually 43.5, so it looks like the first cup was pulling some of the coldness out of the water, but now that the cup is cooled down, it looks like, 43 Fahrenheit for the water. All right, so the third cup here starting to warm up a little bit. We're at 48 Fahrenheit. So it looks like, we're starting to pull new warmer water into the reservoir. So 48, I think, is still cool enough to call chilled water. So now we're on the 4th cup. So the 4th 8-ounce cup of water is up to 52, 53 Fahrenheit. It's still cold water, not quite as chilled. All right, we're on the 5th cup. We're up to 56.7. All right, that's the 6th cup, and we're at to 60 degrees Fahrenheit. So it's cooler than ambient, but it's definitely 20 degrees warmer than your first cup of water. So I would say 3 or 4 cups of water continuously, one after the other, is perfectly fine. If you get a little more than that, it's going to start warming up. Now, just to give you an idea, the fresh or ambient room temperature water over here, that's at 72 Fahrenheit. Now you might notice that the compressor has not yet turned on again. I'm pretty sure it only checks like maybe every minute or so. And so it probably has a delay on the start of the compressor so that it doesn't turn it on and off super frequently. But I am fully expecting this compressor to turn on in the next minute or two and start pulling that water temperature back down in the internal reservoir. So I will time how long it takes to recool all of that water that I've taken out. All right, so there the compressor turned on. It is 10:16 a.m. and I will make a note of when that compressor turns off. All right, this guy turned off at 10:28, so about 11 minutes to fully recycle the reservoir, getting it from that 60 degree back down to the 44 degree. All right, we're going to test the capacity of the hot water reservoir here. It is fully heated up. All right, so the first 8-ounce cup was like 185 degrees. It's going down now that it's warming up the cup, but just coming straight out of there was about 180, 185. All right, second 8-ounce cup, we have here 187. So it looks like the cup has been warmed up pretty well. And so the water's coming out at about 190, 187. We're at 185 now. All right, the water started cooling down there. This cup here, the total cup here is 174, and you might notice this red flashing light, meaning that, hey, the reservoir is getting cool enough that it turned on the heating element. But that was 3 cups of water, and 174 is still plenty hot, I feel. Now the 4th cup of water, this water is getting cooler now. It's about 109, so I'd say that's kind of lukewarm at that point. So your first 2 cups of water, very hot. 3rd cup of water is pretty acceptable. The 4th cup is lukewarm at best. So I'm going to say, definitely 2 cups continuously before this guy really needs to recycle, and you probably want to wait for the light to turn red again if you're looking for really hot water. Alright, so it's 10:31. We're going to be watching this guy and see how long it takes the hot water reservoir to refresh and get back up to like the 190 temperature. Alright, sometime in the last 9 minutes this guy turned solid. I didn't notice exactly when, but less than 9 minutes to recycle the hot water. Alright, last thing to try out is the ice maker. And I just turned that guy on. Alright, so this little round thing flips around and it's filling it up with water. The water starts dripping out to the bottom a little bit. I think it's going to fill up something down here. Alright, I just clicked and turned off. Alright, about a minute after that filled with water, the compressor turned on and now it is starting to make ice. So about 10 minutes after I started the full thing, about 8 minutes after the compressor started, I heard the ice fall. And so we have 1, 2, 3, 4, 5, 6, 7, 8 things of ice from these 8 little round things here. And I'm assuming it's going to flip the container back around, refill with water, and start again pretty soon here. So it looks like that's how much ice you get every 8 to 10 minutes. Now it doesn't look like much here, but that builds up over a couple of hours. There's a little infrared transmitter and receiver on the side here. My understanding is that when this bottom compartment fills up completely with ice and ice stops blocking the path between there, it'll stop making ice on its own. Alright, this guy just dumped another patch of ice. It's filling up and going again, so I think it's kind of hit its stride and it's ready to go. I am going to take all this ice out and then let it run for exactly an hour. Alright, so that's 2, maybe 3 cycles there. It is an ice maker, it is not a freezer unit, so there are little drips of water inside here, and I don't think it will keep ice forever. It's kind of cold in there because it's, has some freezing elements making ice. So the goal here is you turn this on when you need ice and you use the ice, but you don't like store ice in it for more than a couple hours at a time. Alright, it is 11:22. I have set my 1 hour timer, and we will check in 1 hour how much ice it has made. Alright, this is a 6-ounce container, or 170 grams. In 1 hour, and about a minute after 1 hour, this guy dropped a whole nother set of ice and is starting again. So this is basically like 1 hour plus 1 minute worth of ice here. So I think that's a good, accurate representation of an hour's worth of ice production. All right, so it made 45 little ice cubes there. So the weight of that is 703 grams minus your whatever I said before. Alright, so that is 24.8 ounces of ice minus the 6 ounces of the container. So minus the 6 ounces of the container, that's basically 18.76 or 19 ounces worth of ice made in 1 hour. Right, so 45 cubes of ice divided by 9 means it did 5 cycles in that 61-minute period. So say an average of 12.2 minutes per cycle. Alright, the specifications say 13 kilograms every 24 hours. If you do the math, that's about 1 pound 3 ounces in 1 hour, which is just about exactly how much ice I had it make in 61 minutes. So I'm going to say the specification there is spot on. And since the ice capacity generation specification was found to be very accurate, I will trust there are 3 liters an hour for cooling water or 5 liters an hour for heating water. This guy's been running for about 3 more hours, and we're getting close to the level where it might start to trip the IR sensor there. Obviously this ice has some room to slide back into the bottom, so we'll see if it does that or if it trips the sensor. Right, so when this guy completely fills with ice, it breaks this infrared beam and it beeps 5 times and it stops producing ice, so it will never overflow the ice compartment. And that's kind of maximum ice you can get in there. Alright, so I've left the ice maker turned off for 2 hours. It should be noted this is not a freezer, it's an ice maker. And so the only thing keeping these frozen is the thermal mass and the insulation in here. And so you need to use up your ice within a couple hours of making it. So if you have an event, you want to turn this on an hour or two before the event, build up some ice, use it during the event, and then you want to clean out this compartment when you're done, because it will not keep this frozen indefinitely. Alright, well, let's talk about the noise from the compressor. You can probably hear it in the video here. It's not super loud. It's kind of equivalent to maybe a laser printer spinning up. It's a little noisier than a lot of like mini dorm-sized fridges I've seen. It's noisier than my home refrigerator. It's less noisy than a dishwasher, clothes washer, drying machine, anything like that. So if your desk was right next to this water cooler, you could tell when it was cycling on and off. But in a office environment with typical office noises and conversations in the background and people on the phone and things like that, it really wouldn't add a lot of extra noise to that type of an environment. So it's not, I don't think it's too noisy, but here in my house where it is very perfectly quiet, I can tell when this guy turns on and off from about one room away. If the door is closed, I can't hear it at that point. Alright, so right now the compressor is running and it's drawing 125 watts. The manual says it'll draw 500 watts when it runs the hot water heater. So maybe hot water heater and compressor combined is going to be less than 700 watts anyways. I've put this power meter on it. I'm going to run it for 24 hours, just kind of sitting here maintaining hot water, maintaining cold water, not like making ice or not like drawing a lot of water out of it. So just kind of maintenance for 24 hours, just sitting there, and I'll get a power read to see how much power it takes over the course of a day. So the power meter's been on here for 11 hours, 32 minutes, and so far it has used 0.36 kilowatt hours. So it's looking to be probably close to 0.7, 0.8 kilowatt hours per day. So for me that's about 15 cents a day, just kind of idle running, sitting along here. Alright, I've been monitoring this for 23 hours and 59 minutes, so basically a whole day. And in that time it has used 0.82 kilowatt hours, or 820 watt hours. So less than a kilowatt hour per day to operate this guy, just kind of sitting around, not delivering a whole bunch of hot or cold water. Now, because this is an ice maker and not a freezer, if you leave ice in it for a while or the ice just melts a little bit, you're going to get liquid buildup down here. And there's a switch that if it gets all the way up, will just stop making ice because you have all this water in here. But it's kind of up to you to drain this. And that's what the drain on the back is for. So there's a helpful sticker here that says discharge outlet from ice maker. And so you pull off the thing here and there is a plug, and you pull the plug out and it starts to drain. It shoots out a couple inches, so you need to have a container big enough to catch that. And I'm assuming at some point it's going to start dribbling a little bit. In my container I need to carefully position so it's very close underneath that guy so it'll catch any dribbles. It's not pressurized, it's just gravity fed. But this guy drains out. Now, if you're lucky enough to have a drain near where you're putting this, where you can hook on a tube and pipe it to the drain, you could permanently mount this to a drain, just gravity-fed drain, but it would have to be lower than about 4 inches off the floor here. So if you're making use of the ice machine, unless you're using that ice pretty much immediately, it's likely you're going to have to drain this every so often. So it took a couple of minutes. This guy's drained out. It stopped dripping. No, I didn't quite stop dripping. Hit it with my finger, and apparently I started the drip a little bit more. But it's basically just to the dregs here. Put this plug back in, screw this back on to hold it, and it's ready to go. So I'm not measuring the exact amount here. I'd estimate maybe 4 cups of water. But there's a relatively substantial amount there. So you want a big enough container that can catch it all unless you want to be trying to stop it and start it. So once we've done that, you can see in here, most of the water is gone. There's just, a little bit of wet dampness at the bottom there. It might be something where if you're not using this all the time, you might want to leave the door open to let it dry out until you use it the next time. All right, I've ran 5 gallons or almost 5 gallons through this guy, and we're going to lift this guy out and take a look and see what's going on with the water left inside. All right, so I can open this guy up. Look in there. Not much water inside there. There's a little bit on this kind of plastic thing. And really what I want to know is what's up with this drain here that says guard against scald. So I'm going to open that up and see how much water comes out. All right, first I'm going to see how much more water I can get out of the taps, because that little drain plug on the back is lower than these taps. Now I have deliberately left the hot water heater off for at least 12 hours before I got down to empty, so there shouldn't be any hot water in there. But there does appear to be a decent amount of cold water still, even though the 5-gallon jug was empty. So it looks like there's a significant amount of reservoirs in here. Okay, there I ran low. Now I think the fresh water should be mostly low as well. That's empty. All right, now the hot water probably has its own hot water reservoir and an interlock. All right, so it looks like I've gotten everything out that I can from the taps, so let's try the drain on the back. Alright, so the hot water hasn't been turned on for a long time, so there shouldn't be any hot water in here. There is some water coming out, and it kind of goes at an angle. So I'm not entirely certain what I'm draining here. I think it might be something as part of the hot water heater, but it might also just be some internal container. Whatever it is, it's below the gravity feed level of the taps, because I've already drained the taps. This might be something you really only need to drain for transport, maybe. It's not like the ice reservoir drain, which is when the ice melts, it fills up. I kind of get the impression that as long as you're putting more and more water jugs on top, you never really have to open this guy up. But there is a drain back here. The manual really doesn't say what that drain is for. Alright, I got about 4 cups of water out of there. I'm not exactly certain where that is, and if I had to guess, I'd say it was the hot water reservoir, just because of this sticker. But I believe that is all the water out until I put another 3 or 5 gallon jug into the top. So the summary is, when you first plug this guy in, it takes about 12 minutes to heat up the hot water and 20 minutes to get the reservoir of cold water down to temperature. You do have to provide your own 3 or 5 gallon jug of water to put on the top of it. Now after that, you can get 3 cups of very cold water, and the 4th cup is quite chill, but then after that it starts warming up. So if you have just 1 or 2 people coming in getting a glass of cold water every so often, not a problem. If your entire factory gets off work at 10:15 and comes in and always tries to get cold water, it won't do more than 4 or 5 cups of kind of cool water. Now it only takes about 11 minutes to refill or recycle that cold water, and then it's ready to go again, but it's kind of for occasional use or intermittent use. And same thing with the hot water. It'll do the first 2 cups of hot water are more than 185 Fahrenheit. The 3rd cup is about 174 Fahrenheit, which is perfectly acceptable. But the 4th cup is lukewarm. It's like 109 Fahrenheit. And then you have to wait, less than 9 minutes and it's heated back up again. So this is designed for, somebody comes into the break room, they want a cup of hot water for coffee or tea, or they want a cup of cold water, and it's there. And then it recharges, the next person comes in, it's ready again for them. Now it also has a little compartment on the bottom. You turn on the ice maker, it'll start making ice into that thing. It does about every 10 minutes, it drops 9 ice cubes in. Over the course of an hour, this gets to be a little more than a pound per hour. And so it'll fill up the bottom container until it hits an infrared beam and it'll fill up the ice container there. Now it's not a freezer, so you have to use the ice just like an ice machine because it will eventually melt and you'll have to pour some water out of the drain at the back. But it generates ice. So if you have an event coming up, you come in at 9 a.m., you turn it on, you're going to have, 3 or 4 pounds of ice by the time your lunchtime runs around. And so it's very useful to replace like a countertop ice machine because it has the water supply there, and so it can make ice continuously from that water supply, at least until your jug runs empty. So I've found that it does exactly what it says it's supposed to do. It gives you hot water on demand, it gives you cold water on demand. You can also get just room temperature water. There's a center tap if you don't want super hot or super cold water. And then it makes ice for your events. So if you're looking for that combination setup, it does a pretty good job for that.